It's Mrs. Mafucci, and right now let's consider energy changes that accompany phase changes. We are going to consider solids, liquids, and gases. In this video, we will not be considering plasma. In order to change a solid to a liquid, the solid must absorb energy. This is melting. Melting is an endothermic process. When a liquid changes into a solid, energy must be released. When a liquid changes into a solid, it's called freezing. Freezing is an exothermic process. When a liquid changes into a gas, energy must be absorbed. This is an endothermic process known as vaporization. And when a gas changes into a liquid, energy is released. This is an exothermic reaction, and it is called condensation. Now, a solid can go directly to a gas without going through the liquid phase. This is also an endothermic process. Energy must be absorbed by the solid. This phase change is known as sublimation. When a gas loses energy and becomes a solid, it is referred to as deposition. Deposition is an exothermic process. Let's consider a gas going to a liquid. That's exothermic. There has to be a release of energy to the surroundings. Condensation is gas going to a liquid and energy is released. Notice the energy is on the right side of the equation. This makes it an exothermic reaction. Freezing is also an exothermic reaction. It's when a liquid changes into a solid and energy is also released. To go from a solid to a liquid, energy must be absorbed. This is an endothermic process, referred to as melting or fusion. Notice energy is on the left side of the arrow. Energy must be absorbed. This is an endothermic process. And to change a liquid into a gas, boiling or vaporization, energy must be absorbed. This is an endothermic process. Let's consider the heating curve for water. Intervals A, B, C, D, and E represent the heating curve for water. Interval A is when water is ice. It is below its freezing point. In interval B, depending on the direction you're going, you could be melting or you could be freezing. Notice that in interval B, the temperature is constant. Kinetic energy is constant. That's because in order to melt B, all the energy is being used to break the intermolecular forces of attraction. On the other hand, when you're freezing, there's no change in temperature because all the energy that's being released is being used to reform those intermolecular forces of attraction. Remember, when bonds break, endothermic. When bonds are formed, exothermic. Interval C represents the liquid phase of water. Notice it goes from the freezing point of 0 degrees to the boiling point of 100 degrees. Interval D represents another phase change. The red arrow represents the endothermic process, when energy is being absorbed. The green arrow represents the exothermic reaction, when energy is being released. Interval E is when water is in the gas phase, or when it's steam. Remember, there is no temperature change during a phase change. So let's consider the freezing point of water, which is 0 degrees, but it's also its melting point. So water freezes at 0 degrees and water melts at 0 degrees. So what do you have, water or ice? Well, really, you have both. And it depends on what's going on. For example, if it's going through an endothermic process, it is changing from ice into water. Energy is being absorbed to break the intermolecular forces of attraction to change ice into water. But if it's going through an exothermic process and energy is being released, lost, that means it's changing from water to ice. Those strong intermolecular forces of attraction are reforming when water changes into ice. So let's consider this beaker of ice water. The system. If you have an endothermic reaction, that means energy is being absorbed. That means delta H of the system is greater than 0. In other words, it's positive. If energy is entering the system, that means you have the melting process. On the other hand, if you have the exothermic reaction, in other words, the system is losing energy, that means that delta H is less than 0, delta H is negative. It's losing energy to the environment. This is what freezing is. So if the system is absorbing energy, the ice is melting. If the system is losing energy, the system is freezing.